In this video, we're going to look at the graphs of cotangent of x and secant of x. So these are very similar to tan and cosecant that we already looked at. So let's start with cotan. So remember, cotan of x is cos of x over sine of x. We're going to remember that it's going to have vertical asymptotes when sine of x is 0. Okay, so that's at all multiples of pi, okay, where k is an integer. So we're going to have an asymptote at 0. And then at pi, okay, it would be at 2 pi, but our graph doesn't go any further. Also one at negative pi. Okay, so those are some vertical asymptotes that we're going to have. Now, cotan is 0 when the top is 0, so that's when cos of x equals 0. So that's going to be at pi over 2 plus multiples of pi. So at pi over 2, our value is going to be 0. Okay, so halfway between 0 and pi is pi by 2. Okay, and this is negative pi by 2. Okay, this is negative pi by 4, pi by 4, 3 pi by 4, negative 3 pi by 4. So we're going to have zeros, so at pi by 2 and at negative pi by 2. I did those in the opposite order. Now at pi by 4, remember sine and cos are the same. They're both root 2 over 2. So cotan of pi by 4 is going to be 1. Okay, so let's put 1 here. Okay, so cotan of pi by 4 is 1. Okay, 3 pi by 4. This one is in quadrant 2. Okay, so that means that the sine of 3 pi by 4 is positive, and the cosine of 3 pi by 4 is negative. And they're the same, except one's positive, one negative, so this is going to be negative 1. So at 3 pi by 4, we're at negative 1. Okay, similarly at pi by 4, we're going to be at negative 1, because that's quadrant 4. So that's where cosine is positive, but sine is negative. Okay, at negative 3 pi by 4, that's going to be quadrant 3, and that's where they're both negative, so that's actually going to be 1. So it's going to look like the tan graph, but kind of flipped over. Oops. That's not very good. So I'm going to approach the asymptote up here, come down to our 0, and then approach the asymptote this way. So it's just going to continue like that. Okay, so that's what our graph, so here it's going to be down here. Okay, and it continues like that. And up here, it's going to be like so. So that's our graph for cotan. So notice that one interval, so one cycle would be from 0 to pi. So that is going to have length or period pi. Okay, so the domain, x cannot be integer multiples of pi. Okay, that's where our vertical asymptotes are. So I'm just going to fill that in. Okay, the range, again, is all real numbers. So the boldface r, which is negative infinity to infinity. So we can reach all y values because our graph goes to positive infinity everything in between, and then also to negative infinity. So we can get all y values. Okay, here we do not have a y-intercept because x cannot be 0. Okay, but we do have some x-intercepts at multiples of, so pi by 2 plus multiples of pi. So the x-coordinates are going to be pi by 2, oops, plus some integer multiple of pi. And of course the y-coordinate is 0. Okay. Cotan, again, is an odd function, so it's symmetric with respect to the origin. So again, because sine is odd and cosine is even, that's why we get an odd function here. And it has period pi, just like tan. I'm just going to write, it repeats itself every pi, so every interval of length pi. Okay, so that's the graph of cotan. You can see that it looks very similar to the graph of tan. So the asymptotes are moved, so the asymptotes of the asymptotes and the x-intercepts swap places for tan and cotan because the numerator and the denominator swap places. But and then it sort of goes the other direction. Okay, so let's try secant. So again, secant is going to be very similar to cosecant, but we're going to start with the graph of cos x. Okay, so I'm going to graph cos of x. So remember, we start at 1, and then down to 0, and then to -1, back to 0, back up to 1. Okay, and then it continues in that pattern. Okay, so our graph for cosine looks like that. Okay, so that's y equals cos x. Okay, so this is pi by 2, pi, 3 pi by 2, 2 pi, etc. So this is negative pi by 2, negative pi, negative 3 pi by 2, negative 2 pi. Okay, so that's what it looks like. So we want to remember that secant is 1 over cos of x. Okay, so wherever cosine of x equals 0, that means that secant of x does not exist there. Okay, so that's where we're going to get our vertical asymptotes. So everywhere that cosine is 0, so I have a vertical asymptote here, here, here. Okay, so everywhere that I have an x-intercept in my cos graph. Okay, so that's x equals pi by 2, x equals 3 pi by 2, x equals 5 pi by 2, x is negative pi by 2, x is negative 3 pi by 2, etc. So all of those are going to be vertical asymptotes. Now when cos of x equals 1, that's secant of x is 1 over cos of x will be 1 over 1, so also 1. Okay, so wherever it's 1, that point is also going to be on the graph of secant. Okay, now cos of x equals -1 means that secant of x is 1 over -1, so -1. So those points are also on the graph of secant. Okay, and then you want to approach the asymptote. So when we're in this interval here, the cosine values are positive. So I have 1 over a positive number. That's going to be a positive number. So I'm going to have to approach the asymptotes towards positive infinity. Okay, when I'm in this interval, my cosine values are negative. So I take 1 divided by a negative number. That's going to be a negative number. So I'm going to have to approach the asymptotes this way. Okay, and then that's just going to repeat. So if cosine is negative, so is secant. And one more over here. Okay, so that's the graph of secant. And now when we want a period, we need a positive one and a negative one. So this would be one cycle. Okay, so it goes from negative pi by 2 all the way to 3 pi by 2, and that is a length of 2 pi. So those have the same terminal side, so that's a full rotation. Okay, so then the domain here is, so I can't have x, so x is not equal to pi by 2 or any integer multiple of pi added to that. Okay, so the vertical asymptotes are exactly those. So the equations, I just have to have an equals there. Okay, the range, like for secant, I can't get any y values that are in here where the cosine graph is. So I have to be 1 or bigger or -1 or smaller. Okay, so my range is going to go from negative infinity to -1, including -1, and then from 1 to infinity. There is a y-intercept. So here it's when x is 0, y is 1. The x-intercepts, there's none, because we cannot have y equals 0. Okay. Secant is an even function, so this one is symmetric not to the origin, to the y-axis. Okay, so that's because cosine is even. So secant of negative x is 1 over cos of negative x, and cos is even, so that's 1 over cos of x, okay, which is secant of x. So here we have period 2 pi. So again, it repeats itself every interval of length 2 pi. So in our course, so you could do transformations on these graphs. We're going to focus on sine and cosine. So you won't be responsible for doing transformations on these graphs, but you should know what these particular graphs look like. Okay, so I should write here in blue, the blue graph is the graph of secant of x. Okay, so that's what secant and cotan look like.